In this video, we're going to talk about how to calculate the voltage drop across a resistor. So let's draw a circuit. So this is the electrical symbol for battery, and that is for a resistor. Now this is the positive terminal of the battery, and here we have the negative terminal of the battery. Now we're going to use a 20-volt battery. This is going to be R1, and this is going to be R2. Let's give R1 a value of 2 ohms, and R2 is going to be 3 ohms. What is the voltage drop across R1? And what is the voltage drop across R2? So what do you think we can do to find the answer? In order to calculate the voltage drop across a resistor, you need to know the resistance and the current flowing through the resistor. So first, we need to calculate the current flowing in the circuit. So how can we do that? Well, first we need to know what type of circuit we have. And this is a series circuit. The reason why it's called a series circuit is because the current has only one path to flow through these resistors. So these resistors are in series. Now, in a parallel circuit, the current can flow in multiple directions. When there's multiple paths for the current to flow, then you have a parallel circuit. But in a series circuit, there's only one path for the current to flow. Now, the current that we're dealing with is conventional current, where it flows from the positive terminal to the negative terminal. But keep in mind that electrons, they flow in the opposite direction, from the negative terminal of the battery to the positive terminal. Now, before we can calculate the current in a circuit, we need to determine the total resistance. For resistors in series, the total resistance is the sum of all the resistors. So in this example, it's simply 2 plus 3, which is 5 ohms. So that's the total resistance of this circuit. Now, to calculate the current flowing in a circuit, we're going to use the voltage of the battery and the current flowing in this circuit times the total resistance. So this comes from Ohm's law, V equals IR. So the voltage of the battery is 20, the total resistance is 5, 20 divided by 5 is 4. So the current flowing in the circuit is 4 amps. Now once we have the current, we can now calculate the voltage drop across each resistor. Now we're going to use Ohm's law again, V equals IR. But the voltage across resistor 2 is going to be the current that's flowing in the circuit times resistor 2. So we have a current of 4 amps times a resistance of 3 ohms. So that gives us a voltage drop of 12. Now V1 is going to be I times R1. So that's a current of 4 amps times a resistance of 2 ohms, which is 8 volts. So let's talk about what this means. If you were to take a voltmeter and connect it across R1, if you do it properly, you're going to get a voltage of 8 volts. If you do so across R2, you're going to get a voltage of 12 volts. Notice that the sum of the voltage drops in this circuit is equivalent to the voltage of the battery. And it should be that way according to Kirchhoff's voltage law, which states that the sum of the voltages around a closed loop must add to 0. Now, the battery delivers energy to the circuit, so we're going to give it a positive voltage. And the resistors, they take away energy, they consume energy from the circuit, so we'll give it a negative voltage. Thus, they're called voltage drops. So if you add positive 20 with negative 12 and negative 8, you're going to get 0. So that's how you can calculate the voltage drop across a resistor in a circuit like this. But for the sake of practice, let's try another example. So this time there's going to be 3 resistors instead of 2. So we're going to call this R1, R2, and R3. Now the voltage of the battery is going to be 36 volts in this case. And R1 is going to have a value of 5 ohms. R2 is going to be 4 ohms. R3 is going to be 3 ohms. So go ahead and take a minute and work on this example. Calculate the voltage drop across each resistor. Feel free to pause the video to try this problem. So let's begin by calculating the total resistance. So R1 plus R2 plus R3. So that's going to be 5 plus 4 plus 3. 5 plus 4 is 9. 9 plus 3 is 12. So the total resistance in this circuit is 12 ohms. Step 2 is to calculate the current in a circuit. So because it's only one path for the current to flow, all 3 of these resistors are in series. The current is going to be the voltage of the battery divided by the total resistance of all the resistors in series. So the voltage is 36 volts, the total resistance is 12 ohms. So 36 divided by 12, that's going to give us a current of 3 amps. So now that we have the current in the circuit, we can now calculate the voltage drop across each resistor. So let's start with V1. V1 is going to be the current times R1. So that's a current of 3 amps times a resistance of 5 ohms. So that gives us a voltage drop of 15 volts. Now let's move on to V2. The voltage drop across R2 is going to be I times R2. So that's a current of 3 amps times 4 ohms. So that gives us a voltage of 12 volts. And now to calculate the voltage drop across R3, it's going to be I times R3. So 3 times resistance of 3, which is going to give us 9 volts. So now let's add these 3 numbers, 15, 12, and 9. So 15 plus 12, that's 27. 27 plus 9 is 36. And that's a quick way to tell if you perform this problem correctly. So these are the voltage drops of each resistor. That's how you can find them. Now let's work on a different type of problem. So let's say we have these 2 resistors and 3 points of interest. We're going to call this point A, point B, and point C. And let's say R1 has a resistance of 8 ohms and R2 has a resistance of, let's say, 15 ohms. Now let's say the potential at point A is 50 volts and the potential at point B is 10 volts. What is the voltage drop across R2? And what is the electric potential at point C? Feel free to pause the video and try this problem. Now, what do you think is the first thing that we should do? The first thing we need to do is calculate the voltage drop across R1. The voltage drop across R1 is the difference between the electric potential at point A and point B. It's the potential difference between those 2 points. So it's 50 volts minus 10 volts, which is 40 volts. So that is the voltage across R1. Now, in order to calculate the potential difference or the voltage drop across R2, we need to determine the current flowing through R2. Now, because there's only one path for the current to flow through these 2 resistors, these 2 resistors are in series. So we need to calculate the current flowing through R1. We'll call it I. So let's use Ohm's law. V is equal to I times R. So V1 is going to be equal to I times R1. V1 is 40. That's the voltage across R1. And R1 is 8. Dividing both sides by 8, the current is going to be 5 amps. So if 5 amps of current flows through R1, then the same amount of current flows through R2. So now we can calculate the voltage across R2. So V2 is going to be equal to I times R2. The current is 5, R2 is 15. 5 times 15 is 75. So that is the voltage drop across R2. It's 75 volts. Now, let's calculate the potential at point C. The current flows from a high electric potential to a low electric potential. So as the current flows from A to B, this tells us that B is lower in potential than A. Now the current flows from B to C, which means that C is at a lower potential than B. Now we have the potential difference between points B and C is 75, and B is higher than C. So C is going to be 10 minus 75, which is negative 65. So that is the electric potential at point C. And that's basically it for this video. So now you know how to calculate the voltage drop across a resistor. So basically, you need to use Ohm's law. V is equal to IR. You need to know the value of the resistance of the resistor, and also you need to know the current flowing through that resistor. If you multiply those two things, you'll get the voltage drop across the resistor. So that's it for this video. Thanks for watching, and don't forget to subscribe.